Here we're going to look at graphing an ellipse. So fancy name for an oval shape. And so one first thing we want to look at is for ellipses that are centered at 0, 0. The standard form for the equation looks like x squared over a squared plus y squared over b squared equals 1. So if we look at our equation, notice it doesn't equal 1. Well, what can we do to both sides to make it equal 1? We'll divide everything by 144. Right, so now we're successfully turning this into an equals 1 problem. So 9 goes into 144 16 times, and looks like 16 goes into 144 9 times. So this becomes 1x squared over 16 and 1y squared over 9. Okay, so we can see from there what's a and b, because notice these numbers 16 and 9, they're not a and b, they're a squared and b squared. So if a squared is 16, I can say that a is 4, and if b squared is 9, I could say b is 3. Alright, so you'll notice this, and maybe the explanation broke down into a few different cases with the major and minor axis. We don't really have to make it all that complicated. The major axis just means the longer one, and the minor axis means it's the shorter one. And so it doesn't matter which one of these I call A and B. The thing I try to remember about them is the one that's with x tells me how far to go back and forth from the center, because x is a back and forth value, and the one that's under y tells me how far to go up and down from the center. So in this one, I know the center is 0, 0. So if I want to go graph it, I know the center is at 0, 0, so I'll mark that first. And then I know how do I get to endpoints on this axis. I go 4 in either direction because a is 4, and that's one with x, so that's why it's back and forth. So 1, 2, 3, 4, I know that's an endpoint. 4 in the other direction, I know that's an endpoint. And then for b, being with the y, I go up and down 3 units. So there's an endpoint, and there's an endpoint. So if I connect those all together, I get an ellipse, or this oval shape.